Assalamualaikum and hi. We are from Starlight Holding, here to promote about Dicom in this National Medical Imaging Conference. So let's start with the introduction. Standardization of information in healthcare institutions through one specific system is one of the most important things in medical field. Why is that so? It is because the access to the patient's entire relevant clinical information is the main source to assist in healthcare decisions. For example, just imagine that you are the patient and you met lots of different doctors, especially in government hospitals. If there is no standardized information, just imagine how many times that you have to repeat symptoms and signs that you have. Nowadays, with the advance of technology, patient care is improved as the health record can be accessed anytime and anywhere. Talking on about the standardization, Dicom is also one of the software. Dicom stands for Digital Imaging and Communication in Medicine. Through the name itself, we can know that this software is specifically for digital imaging. So, how exactly Dicom help in digital imaging? Dicom is actually a format for medical imaging. The basic definition for Dicom, according to TechTarget website, a website with experts in technology and software, Dicom is a standard protocol for the management and transmission of medical images and related data and is used in many healthcare facilities. There are 5 layers of functionality, which are: first, transmission; second, query and retrieval; third, performance; fourth, workflow management; and lastly, quality and consistency of image appearance. So, to simplify, Dicom is used for digital data exchange and interchange among electronic devices used in medical imaging. However, it only speaks to the behavior of devices used in PACS. Dicom is used in almost every radiology imaging, and radiotherapy devices, and now has been widely used including ophthalmology and dentistry. Moreover, Dicom has its own standard committees. Committees include the government agencies, manufacturing associations, and international committees, which our company is also part of the committee. Almost all medical system manufacturers and producers subscribe to Dicom standard. This proves that Dicom is the standard. So that's all for the statement of Dicom. Now let us get deeper into Dicom.
You guys must be wondering how the Dicom actually works. First and foremost, the Dicom data model supports a hierarchical medical imaging workflows that consists of several processes. All aspects of the workflow are managed by the central server, which is called PACS. The first process represents the initial patient registration. Patients usually come to the radiology department as scheduled for their examination. RIS is now updated with the new status of the patient. The second process consists of one or more studies such as procedures or medical examination. Patient will undergo one or more examination, so when the images are captured and generated, it will be stored in the Dicom format. Dicom ensures that images are stored in a standard format. It is because we are using the universal standard format to store the image and also can transfer the image using the same format. After that, image will be transferred to PACS for storage. Radiologists can access the image through PACS onto their computer for diagnosis. So by using a Dicom viewer, doctors will interpret the image, make a report and print using a Dicom print better before consulting with their patient. Actually, Dicom was introduced in 1980 by American College of Radiology (ACR) and National Electrical Manufacturer Association (NEMA) to address the issue of vendor-independent data formats and data transfers for digital medical image. At the beginning, it was very difficult for technologists or CT or MRI to decode the image that are generated by the machines or to print them. So in 1983, ACR and NEMA collaborated and formed a standard committee to address the needs of radiologists, physicists and equipment vendors. In 1985, ACR NEMA 300 was released, which is the first standard covering point-to-point image communication. At that time, a dedicated 16-bit parallel interface was used for image transmission. ACR NEMA 300 is the previous name before the Dicom. However, due to an increase in acceptance among the vendors, a second version of ACR NEMA 300 was released in 1988. During 1993, the third version of the standard evolved to make use of local area networks such as Internet by layering medical image protocols on top of general networking protocols TCP/IP. At this time, the name was changed to Dicom and published as NEMA Standard PS3. In 1995, Dicom was used in US X-ray angiography and nuclear medicine protocols supporting the needs of cardiology imaging. A year later, workflow management was standardized in the imaging department in 1996 and added to the modelist worklist service.
Dicom technology offers many advantages, including the fact that it provides better communication with the referring physicians. Referring physicians prefer to read an organized report. Structured reports can be both brief and in-depth. They are easier and faster to read, especially when key structural elements are highlighted for visible. For example, the presence of a mass, its dimension, position, and characteristics can all be automatically displayed or printed in bold to communicate important information to the reader more quickly, easily, and effectively. Next, high-performance review. When images are viewed, the extension in which Dicom images are stored performs well. The most data is contained in the highest resolution captured by an image scanner. Supplement 145 suggests a method for storing large image in pathology as well as how to map subregions from the layer into the Dicom series. Tiles are subregions that are stored in squares, which are then stored into the arrays. Additionally, single network transactions could transfer both patient and image information. Lastly, references to image and presentation states. Image can be references inside the document by including their Universal Unique Identifier (UID) in a note. Moreover, semantics associated with the reference object conveys the purpose of reference. Image frame numbers can also be specified to reference explicit frames within a multi-frame image. A presentation state instead may also be associated with the reference image to ensure the image are displayed consistently by specifying the geometrical and grayscale contrast transformations to be used, such as the correct orientation, zoom factor, and window settings. For example, the radiologist may point the arrow to a specific feature in an image. This data can be saved in a presentation state. The image and its presentation state can be referred from the report content. The image will be embedded within the rendered report's content, and the arrow will be properly displayed. One of Dicom's advancements include the role of Dicom in artificial intelligence for skin disease. Dicom is a constantly evolving medical imaging standard, with supplements and corrections being added on a regular basis. As AI image classifiers become more popular in medical imaging, the Dicom standard is being updated to AI-specific content. A special AI working group is part of the Dicom Standards Committee. This working group's mission is to create a Dicom mechanism that can support AI workflows and encode AI artifacts. Image acquisition and review workflows are likely to improve with the use of Dicom. The amount of time radiologists spend on image review has been shown to be significantly reduced without compromising diagnostic accuracy. Dicom's ability to encode relevant metadata and provide connectivity with the digital health ecosystem sparked initial interest in its use in dermatology. By encoding derived objects such as secondary image, visual explainability maps, and facilitating the curation of multi-institutional datasets for machine learning training, testing, and validation, Dicom can improve AI workflows.
Dicom is preferable to use because it is facilitated and particularly important in compliance, workflow, diagnostic, data accuracy, and administration. First, compliance. Generally, Dicom has introduced the modality perform procedure step, which is MPPS, to enable legal compliance and assess quality control. For example, track and record radiation information. Dicom deprivation was to help the medical practitioners be able to plan the precise amounts of dosage used for radiation therapy. Besides, Dicom verifies compliance with the standard by values detailing for some data. For example, right and left mandatory options for the laterality attribute. The second is workflows. It can manage the workflows using the system's interoperability, which is enabled by the Dicom. The workflow involves produce, store, display, query, process, retrieve and print medical images. Additionally, an optimized procedure scheduling, exposure durations, and accurate reporting about workflow is allowed by the service of the Dicom. Then diagnostic. Dicom has replaced JPEG and TIFF, which are traditional image standards that do not provide patient and procedure information, so they are not useful for diagnostic purpose. Instead, Dicom datasets contain valuable information about the patient, the examination, the equipment used, the medical practitioners, and equipment operators involved, and also the scope of examination. Next, data accuracy. At the acquisitions equipment endpoint, a single point of enter data permits data accuracy. MPPS messengers provide a precise information that refer to making decisions by the acquisitions operators with the enabled Dicom protocol. The example of the MPPS messengers is about cancelling or modifying a procedure. Furthermore, MPPS messengers also transmit exceptions and error messages and automatically warn other systems and users about the errors. At last, administration. Film, device and supplies that are also known as a consumables collected by the MPPS regarding the information. Not only that, MPPS enables billing and listing management automatically. The Dicom storage commitment service ensures the images from the acquisition equipment will be stored separately, which can be released when using a different procedure that acquire a new images. Moreover, a medical personnel can check files out and log them for the updates that are allowed by the archiving system in order to view the files. Indeed, it is apparent that Dicom plays a significant role in medical imaging world to share data between thousands of different devices across the world as quickly as possible. In turn, Dicom gives the biggest influence on the high quality of efficient patient care together with viewing valuable information for the healthcare professionals to refer to. Not all medical images follow a Dicom format. Nevertheless, the availability of service of Dicom has brought the contemporary facilities for physicians in working as well as Dicom remains bright in the future. These affirmations pointed out that Dicom standardized has switched the way of the world medical imaging, perceived the importance of universal image accessing from different vendors' devices. That's all from our company.